Hello students, in this lecture we will talk about the famous pigeonhole principle. The main statement of the pigeonhole principle, the pigeonhole principle, okay? So the main statement is, if more than n objects, if more than n n objects are distributed into n boxes, then at least one box must receive more than one object. Okay? So suppose you have 4 boxes, okay, and you have 6 pigeons, okay, then you if you are trying to put these pigeons into 4 boxes, then at least one of these 4 boxes contains at least more than one elements, okay. So this is the main thing of our pigeonhole principle, okay. So this is the first form of pigeonhole principle. We call it by PP1, okay. Now the second principle, or the second form of this principle, second form of pigeonhole principle, which is called by PP2, is for any positive integers, n and t, if tn plus 1 or more objects are placed in n boxes, n boxes, then at least one box then at least one box contains more than t elements. Okay. Now third form is PP3. Third form is if the average of n positive integers is t, then at least one of the numbers is greater than or equal to t. Okay. Further, one of the numbers is less than or equal to t, is less than or equal to t. Okay. Now the proof of this PP3 is very simple. Okay. Proof: if A1, A2, AN be the numbers, then by the data the average of n numbers is A1 plus A2 plus dot dot n whole divided by n. Okay, is equal to t, so that A1 plus A2 plus dot dot an is equal to tn. Okay, hence if each of the n numbers, hence if each of the n numbers A1, A2, AN less than t, okay, then the sum of A1, A2, AN is less than nt. Okay, which is a contradiction. Okay. contradiction. Okay, so this method is called the method of contradiction. So sometimes in mathematics we prove a theorem by method of contradiction. Okay, okay, now the last principle, which is called PP4. Okay, these are all equivalent. Let Q1, Q2, Qn be positive integers. Okay, if Q1, Q2 plus Qn minus n plus 1 objects are put into a box, are put into n boxes, then either the first box contains at least Q1 objects, or the second box contains at least Q objects, at least Q2 objects. Okay, or the nth box contains at least Qn objects. Okay, so when we do problems on Pigeonhole principle, then we will use one of these four principles. Okay, so now I will do some problems. Problem 1, suppose numbers of 1 to 20 are placed in any order around a cycle. Okay, around a circle. Show that number 1, the sum of some three consecutive numbers, the sum of sum 3 consecutive numbers must be at least 32. Okay, and the sum of 4 consecutive numbers at least 42. Okay, so just you have to understand what is the problem saying. Okay, so this is our circle. No. Okay. This is our circle. Okay, so we have to put numbers according to some orders. Okay, okay, so let solution. Let A1, A2, A3, A20 be the numbers placed around the cycle. Okay, placed around the circle in some order. In some order. Remember that A1, A2, A20 are the numbers of 1 to 20. Okay, since the min of 3 consecutive numbers, namely A1, A2 plus A3, A2 plus A3 plus A4, A3 plus A4 plus A5. Okay, so consecutive means A1, A2, A3 are consecutive numbers. A2, A3, A4 are consecutive numbers. Okay, so up to A20 plus A1 plus A2 because they are placed on a circle. Okay, so the sum of these all sums is nothing but 3 into A1 plus A2 plus A90 plus A20. Why? Because in each sum the numbers are occurring in at 3 times. Okay, see here, A3 is occurring 3 times, 1 2 3. Okay, similarly A1 is occurring 3 times, A1 A1. Okay, and the previous term of this of this term of this sum, so A19 plus A20 plus A1. Okay, so each numbers are occurring in each sums, okay, at 3 times. So if we sum up all sums, then the sum is 3 into A1 plus A2 plus dot A19 plus A20. Okay, and we have to show that the 3 consecutive numbers of some 3 numbers is actually at least 32. Okay, so here we have to apply the PP3. So now we are taking the average of them. Okay, so this equals to, see, if we sum A1 A2 A20, that means 1 2 3 20. We have to take the sums. Okay, then we have to write A20 in this way. Okay, so if we have to sum 1 plus 3 plus 20, then we are summing by a tricky method. So this equals to this, and S equals to again 20 plus 19 plus 18 plus 1. Okay, so this is equals to 2S, and if we add them, then 21 21 21. Okay, so 20 times of 21, so 2S is equal to 20 into 21. So S is equals to 20 into 21 by 2. Okay, so this sum is equal to 3 into 20 into 21 by 2 into 20. Okay, so this equals to 31 of 1 by 2. Okay, so by PP3, that at least one sum is greater than or equal to 32. Okay, similarly we can do the second method. Okay, now I am giving this as homework. Okay.